All right, so it's time to look at the side-side angle case. This is where you you know two sides, and then an angle which is kind of adjacent on the out, to one of them. This is also known as the angle side-side case because it's a bit of a pain in the butt. With the first two cases we looked at, angle side angle and angle side, you could actually give any combination of values for those things as long as the two angles add up to something less than 180 degrees to give enough room for the third angle, and you could have that side be whatever you want, and you could solve the triangle. Okay, but with the side angle case, there's some possible values you could pick for the side lengths that will not result in a valid triangle. And there's also some situations where you can have more than one possible triangle that could have those values. So there's going to be differing number of solutions, where a solution would be like a triangle which would satisfy the conditions that you've set down. So I've drawn a few different pictures here to like illustrate the different possible situations we could be in. Let's start by looking at this one in the middle here. So all of these have the same angle A, by the way, and they all have the same side length B adjacent to that. And then the opposite side A, that one is varying lengths. So we're going to break down these cases by how long is the side which is opposite the known angle. So I'm calling them A and A. It doesn't have to be A, it could be the B's or it could be the C's, but the point is it's the side opposite the known angle. So I'm starting with this one because this is the case where that side is just exactly the right length to form a right triangle. And if that, and the length that it would have to be in that situation is exactly B multiplied by sine of angle A. A equals, lowercase a equals B sine of capital A. And you think about the way the sine works. Sine is opposite over hypotenuse, so you divide both sides. So multiply both sides by the b, and you get that b sine a is just the opposite side. Okay, so in that situation, there is one solution. Okay, that's the situation where there's one solution. Now, what would happen if the side A was shorter than that? If side A is actually shorter, still positive in length, but less than b times sine of capital A. If A is in that range, then you have like this little side that would hang down, and you don't know the value of this angle, so it could be anything. But that would hang down, and no matter how you swing that around, it's never going to intersect the other side that you have down at the bottom, right? The other side formed by this angle that you know. So you've got to, in order to form a triangle, this side A has to intersect this side, which will be side C, somewhere, but it can't because it's too short. I like to think of this as like a cat flap. You've got a door and you have maybe like an opening here, and you have an opening for your cat flap, and then the cat flap is attached up here. Okay, and if your cat flap is really short, then no matter how it swings around, then it's never going to. It's always going to leave a blank, like an opening on the bottom. Okay, and that's kind of the situation right here. Is we have this angle up here, but then we have this little short cat flap that doesn't, in the kitty door, it just swings in it, and the cat can always go underneath, so it never opens or never closes. So in that situation, there's no solution. That's a really weird mental image, I guess, but it works for me. This one, it works really nicely over here too. So in this situation, this is where A is a little bit longer than B sine of A. So we could write B sine of A is less than side length A, but it's still less than the length of side B. If it gets longer than B, then we're going to be in case 4 over here. But in this situation, it's kind of in the sweet spot where, in the cat flap analogy, you have a problem with your cat flap because the flap that hangs down, it can't hang straight down. It's like if it were to hang straight down, it would bump into the ground down here, and then you wouldn't be able to leave it there. But what you could do is you could lean it over here, and it could lean on the ground on that side, or you could bend it and stick it through onto the other side and cause it to lean. To lean down on the ground on that side. But it can't hang down because it's too long, right? It can just lean on one side or the other. So that's the situation here where this is a little bit too long to hang straight down, and touch, you'll perfectly meet this side. But if you tilt it to the left or to the right, then it can meet that side perfectly and form two different possible triangles. So I'm going to highlight the triangles in different colors here. One of the triangles is this one. And the other triangle shares the same angle A and side B, but it sticks out here. So this is the situation where you have two solutions. And I'm going to walk through an example of this in a few minutes. The third case is when the length of side A is greater than that of B. So here I've got it kind of sticking off to the right over here. This is meant to be longer than the B. That may or may not be obvious. But the issue with this is it can stick off to the right. If you try to make it stick off to the left, then you have a problem because it would stick out over here. And it would intersect this side, this dotted line, side C. It would intersect that side on the left side of the angle, which is impossible. Because if you make this shape, I don't know about you, but like I wouldn't call that shape a triangle personally. So like that wouldn't count, right? That doesn't form another possible triangle. The only triangle is formed by making that side stick out over there to the right. So this brings us back down to one solution. And this case extends off forever. You can make side A as long as you want relative to side B, and you can always form a triangle by having it stick off to the right somewhere. So there we go. So this gives us like a sort of spectrum of different possible cases. As we take the length of side A, and as we make it bigger, there's going to be this realm where there's no solution, and then there's going to be one exact value where there's one solution. Then we're going to have a period of time here where we have two solutions, and then once it gets too big, we're back down to only one solution again. So when you're in a side-side angle problem, what I recommend doing is first calculating the value of B sine A, and then checking the value of A against that value to see if you're in this situation, or this situation, and then also check it against the value of B to see if you might possibly be in this situation. That's going to tell you, doing that is going to tell you which of these three cases you are, which of these four cases you're in. So it'll tell you how many solutions to expect to find. So we're going to do an example where we have a triangle set up like this. We know the value of angle A, we know the value of side B and side A. And so in this case, I'm going to do the example where A is 20 degrees, B is 12, and C is and little a is 6. So first thing I'm going to do is I'm going to calculate what is B times sine of 20 degrees. Well, B times sine of 20 degrees B times sine of A, which, let's put that in A in there, which is in this case 12 times sine of 20 degrees, which in this case is 12 sine of 20, 4.1. Okay, so it's 4.1. So in this case, A, which is 6, this number falls between the 4.1 and the 12, right? So this means we are in the two solutions case. Okay. So you see the value of A is greater than B sine A, right? It's greater than that. This greater than this length, but it's not greater than B, right? So we're not in this case. We're in between. We're in this one. So I can draw the picture here. It should look something like this. Here's angle A, which is 20 degrees. And then here's B, which is 12 units. And then we're going to have two possible situations here like this, where A is 6, and that side of length 6 can either go down, A equals 6 in both cases. It can either kind of stick down to the left or it can stick down to the right. And that means that angle B, so this is side B, the opposite angle here is going to be angle B. It's this angle. There's two different possible solutions. There's going to be one, I'll call this one B, we're going to call this one B, B1, and then we're going to call this one B2. Okay, there's two possible values for angle B. And that's going to give us, of course, two possible values for angle C. We're going to have two possible values up here for angle C, C1 and C2. Okay, and then for the side length C, we also have two possible values. Side C is going to be either this long or this long, right? And this would be C1, and this would be C2, lowercase C1 and C2. So we're gonna end up having like two possible triangle solutions that we're gonna get from this. So the way to start solving for these two triangles I think what makes the most sense here is to use the law of sines to try to get angle B. Because we have our opposite pair, 20 degrees and A equals 6, right? So we have the opposite pair here. And then we have one side B, so you might as well try to get angle B, right? So I'm going to set up the law of sines this time backward, like the upside down way. So far, wait a minute, what am I looking for? Here we go. So far, in the previous examples, we've been using this version with A over sine of something, right? But now we're going to flip it upside down and do the sine over the side length. So we're going to do sine of B, whatever that equals, divided by 12. It's going to have to be sine of 20 degrees divided by 6. Okay, so sine B equals 12 sine of 20 degrees over 6. And there's two possible cases. One is that B is just equal to the arc sine of 12 sine 20 degrees over 6. Or, which we'll get that in a second, and the arc sine is going to give us an acute angle because of the range of arc sine, because of how, arc sine gives you something in this range on the right-hand side here. So in particular, in this case, it should give us something up here, okay, because this ratio is positive. So it'll give us an angle, an acute angle in the first quadrant. So the other possibility, besides that, would be the reflection over the y-axis, which would be 180 degrees minus that value. So we're going to calculate both of these things and see what we get. So the first one is arc sine. We go arc sine of 12 times sine of 20 degrees divided by 6. That gives us one possible angle. I'm going to call that B1 is 43.2 degrees. And then B2 would be 180 degrees minus that answer. And so here B2 is 136.8 degrees. There are our two possible angles. And you can see them. Let's color code them. Oh, hang on. Let me get a green pen here. So let's say B1 here is going to be green. At 43.2, that's the acute angle. So in my picture down here, that's this angle, right? I already labeled it B1 because I knew what was coming here. So I've got that possible angle. That's going to form this triangle, which is kind of the bigger triangle. It's going to give us the larger side C and the larger angle C. Okay. The other possibility is the B2, which I'll do in purple here. Okay, B2 is 136.8. That is the obtuse angle, which is going to correspond to this smaller triangle with the smaller values of C, angle C, and side C. Okay, so let's continue this problem on the next page. So I'm going to scoot this up a little bit so you can see where we are so far. All right, so we're going to break this into two cases. We're going to start with the B1 case, 43.2. And then we're going to put a line, and we're going to do the B2 case, B2 136.8. Okay, so for the B1 case, now that we've solved for B1, now it makes sense to solve for C1. So angle C1 is going to be 180 degrees minus the 20 degrees from angle A and minus this 43.2 degrees from angle B. So that gives us C1 equals 116.8 degrees. So that's the first possibility. And with B1, it makes sense that that C1 would be larger because it's because of the fact that it's got to stick out to the right over here. So now, if we want to solve for side C1, okay, we really, using the law of sines, we really have to go ahead and use this angle. So this is one of those situations where you're kind of forced into calculating using a value that's already been approximated. So we kind of have to just accept that non-ideal situation. We're going to do C1 divided by sine of the angle C1, so 116.8 degrees. that's got to equal, and then now I can go ahead and use the opposite pair that I started with, the A, so 6 over sine of capital A, so 20 degrees, like that. And take that, and we're going to solve that for C1. Here we go. Okay, C1, I'm going to multiply both sides by this sine of 116, so I get 6 times sine of 116.8, and then divide that by the sine of 20. Here we go. And get 15.7 approximately. So this gives me C1 equals 15.7. And so there is the solution. Those three values that I have in boxes right there, that's one solution. This represents the larger of the two possible triangles. The second solution we'll do now, and we're going to solve it exactly the same way, but we're just going to get different answers. So we can still solve C1 by subtracting from 180. This time we're going to subtract to 136. Oh, I see what I did. 136.8. So this is going to give us a C1 equal to 23.2 degrees, approximately. So that's smaller, right? Because with the obtuse b in my picture here, the obtuse b corresponds to a smaller c value, right? This is C2. I forgot I labeled it C1, but that's actually C2. And then now I need to do side C2. So I'm going to do C2 divided by sine of this angle I just found, 23.2. It's going to equal, and I'll go back to the one that I know, the 6 over sine of 20. We'll do this one. There's a lot of calculating on this in this section. 6 times sine of 23.2 divided by the sine of 20. We got here C2 is going to be about 7. If you round that, 7.0. So there we go. And that's our second solution. So this is the going back. This example demonstrates why the side-side angle case is such a pain in the butt. Actually, some textbooks will refer to this as the ambiguous case. The side-side angle situation is the ambiguous case because it's not clear immediately. It's not immediately obvious whether you're even going to have a solution or whether you might have two solutions. But I recommend going back to b sine A and check b sine A and the value of that and compare that against the value of the other side. By the way, it's not always b sine A. It's got to be the side that's not opposite the angle given times the sine of the angle given, and those labels might be different. So please adjust the letters if you need to. But the idea is it should be that equivalent calculation for whatever triangle values you're given. Check that, and that'll tell you which situation you're in, and then you should know what's going on, and that helps you draw a picture. I highly recommend drawing a picture like this, and it just has to be a rough picture, so that you can kind of visualize. And then when you solve for sine, right? When you use the law of sines to solve for the opposite angle down here in the bottom right. You do this thing where you get the arc sine gives you one solution, and then you do the 180 degrees minus the arc sine to get the other solution. Okay, that's how you get the two triangles. At least this is how you start getting the two triangles, right? And then you finish out with two separate cases. Okay, so I know that was kind of confusing, but that's yeah, I hope that made sense.